So let me check. Let me confirm the others. Copy the link and send to me. Let me confirm the others.
You double check.
Just speaking audio. Technology works. Honestly. Responsive. You need the mic on. Yeah. Yes, where we come.
Good morning, everyone. Are we happy to be here? You sure? All right, today we're going to continue our series on the food, energy, and water system research. And today we'll be looking at electrifying mobility. I'm sure most of us want to drive electric vehicles soon. No, Haibo. Okay. But at least we want to develop one. All right, so I would ask us again after the section if we are still interested in driving one or developing one. All right, so today we'll be having Mr. Seaman Carroll. Please permit me to read his citation before he comes up. Sorry. Mr. Carroll's involvement in energy started in 1988. Please, can we have some quiet? Thank you. Mr. Carroll's involvement in energy started in 1988 when he joined the National Energy Council, NEC, a governmental energy forum involving national transport policy. His work focused on alternative transport energy, and this led to the start of a program to evaluate electric vehicle technologies and its application in South Africa. When the NEC closed their doors in 1992, Mr. Carroll continued his career at Eskom, where he directed electric transport programs. National various combustion engines involving petrol and diesel vehicles were converted to electric propulsion. All these vehicles were used and tested under real-life conditions to study operational performance. Eskom stopped doing work on electric vehicles in 2002 when the oil price fell to $12 per barrel. In 2013, Sanedi persuaded Mr. Carroll to take up a career in Sanedi as the general manager of the Cleaner Mobility Program in order to work with national governments to lay the foundations for cleaner mobility in South Africa. Today, Mr. Carroll is involved in various projects providing advice on electric vehicles, solar energy, and energy storage. Please put your hands together as we have Mr. Seaman Carroll.
Can you hear me? I'm not good in speaking into mics. Is this okay? Some of you I've said hello to before, so the rest of you who came later, welcome. And we'll, even though I'm dressed formal, we'll keep it informal. All right, you can talk to me, ask questions. I'm going to tell you a story. This is not a normal presentation. This is a flip through a photo album. I'm going to show you pictures, and we're going to talk to the pictures. And in this way, I'm going to tell you something about the history of electric vehicles at Eskom. Although I started the story many years back, like you've heard, in 1988 already, when I joined the National Energy Council. Now, the National Energy Council was a forum for energy companies in South Africa, and they advised the government on national energy policy. So in the forum, when we had our meetings, steering committee meetings, the energy players in South Africa came together to talk to us about what they wanted to happen. For instance, in the early days, we had to take lead out of petrol because the lead was poisoning people. And we had the motor industry, the likes of Mercedes-Benz, BMW, Volkswagen, Toyota, come talk to us so that we can understand what's going to happen if we take lead out to their engines. And also the fuel companies in those days, the refineries, come to talk to us. And they advised us on these things, and then we put all that information together, and then we write policy for government. So that's where it started. But in 1992, the National Energy Council was disbanded, and the people there were put back into government. Now, I was studying at that time to become an entrepreneur, you know, masters in business leadership. And I said, I'm not going to go back in government. No, man, I must be an entrepreneur now. And I was learning about all these things about electric vehicles, and I thought, what am I going to do? How am I going to do this? Because I'm leaving this now, because they're closing the doors. But on the steering committee of me for electric vehicles, Eskom was there. And Eskom said, why don't you come join us? We'll make you an energy consultant, a full-time one. And then you can work on electric vehicles and continue with the program so that we can understand how electric vehicles work, what it'll do to the grid, and all these sort of good things. So I said yes, and Eskom gave me the opportunity to play with cars again. Now every boy wants to play with cars. And I really enjoyed it very much, and Eskom gave me a very good opportunity to do that. So this story is then about Eskom Pictures, first one. That's the first car that we imported into South Africa. That is a CCP-FEWS. We found them in Boston, close to New York, in America. And they built this little car. They converted this car to electric. And this car had a good range of about 80 kilometers using nickel-cadmium batteries. I don't know if you guys know about nickel-cadmium batteries. Now, the first cell phones that we had nickel-cadmium batteries, so it was a decent battery, better than lead acid, but not that great. But that was the first one. That's why it's called TRI-1. Technology, Research and Investigations number 1. That's the place in Eskom that I worked in Rocheville. But we also played around with go-karts. Because, you know, it's fun to have fun in work as well. You can't just work. You need to have some fun. And the batteries we put into this boxes there, and we had electric vehicle at the back, and we kicked ass with this one because it outperformed the petrol ones. The reason why, it was a little bit heavier, and of course the electric motor has got more torque and acceleration than an engine. The car sat on the road very well, gripped very well, and it didn't slide on the turns. So we can, on the turns, accelerate out of the turn faster than anybody else could. And even though I'm not a racing driver, I competed with the guys that know how to drive these things. And this is the first real high-performance electric vehicle that we imported from the USA. This was AC Propulsion's Honda Civic. Now, who of you have heard of Tesla? Now, Tesla, for their Roadster, went to these guys to buy their first motor. Now, we beat Tesla to that with a couple of years because we imported this car before Tesla even existed. And then I went to the USA and I bought 20 motors so that we can do conversions in South Africa and see if we can do the same thing that the Americans did. Now, I didn't go there to buy 20. I went there to buy one. But then they said the first one will be $40,000. I said, yes, this is expensive for that. I can buy 2 cars in South Africa for that price of the one motor that you're going to give me. So I said, okay, you buy 10, I half the price to $20,000. I said, wow, this is a nice game. What if I buy 20? He said, no, I do the same doubling thing again, halving thing again. You can buy them for $10,000 each. So I bought 20. I had to walk the red carpet when I got back to Eskom. But Eskom was nice to me. Sam Mosakili, he was the head of marketing. And they said, it's okay, but just use them properly. So what we did is we took a Corsa bakkie. You know Corsa bakkie. Why the Corsa bakkie? Because it can carry half a ton. And that's the weight of the batteries in those days, lead acid batteries. But we converted that to electric. And you can see there, I used this car as my primary means of transportation. We did the conversion, I drove it, and I drove it for 8.5 years at Eskom. That's until Eskom pulled the plug on the program. And you can see when we had to exhibit the car, I demanded, I asked nicely, that I can have a space on the exhibition floor. This is in Gallagher, not Gallagher, sorry, Sandton Convention Center. That I have a space that I can drive onto because I wanted to show people that what we put on exhibition is not static. It is something that I use every day. And you can see I put the stickers onto the car and every afternoon I drove out again. And people watched and they were amazed that this exhibition is actually driving out and coming in the following day. But that's the way we caught attention. And we had lots of publicity in those times. Actually, today I can't understand why nobody remembered this or knew about it, because we made quite a lot of noise. This is another bakkie that we converted, this one for eThekwini municipality. The financial department of the electricity department there used this vehicle for a number of months. Interesting thing is, when the batteries are finished, lead acid batteries don't last that long. You go through a pack of batteries in about 2 years if you look after them nicely. And that's why today they are not batteries that are even competing with any technology for electric vehicles. But when the batteries are finished, these guys that have been using the vehicle almost for free, because electricity was very cheap in those days, they don't want to buy another battery pack, because the battery pack cost 60,000 rands in those days. And then I give the vehicle back. And I think that's why you guys said you don't want to own an electric vehicle. I can tell you, I've been driving an electric vehicle since those days, and I will never, ever go back. I'm still driving electric. My car's outside if you want to see it. We also converted, together with Nissan, a big truck, a 4-ton truck, to electric. Now, that same motor that went into the small bakkie also went into this truck. The electric motor is much more powerful than an internal combustion engine vehicle. That's why you hear about these cars with massive kilowatts ratings and Newton meter ratings in the engine. And you don't even need a gearbox. So this spec for this vehicle was it needed to go 80 kilometers far, and it needed to have a top speed of 80 kilometers per hour. So that was not too difficult to do. We put 2 battery packs, one on one side and one on the other side. These batteries were spiral woven batteries, very good deep cycle batteries. That's also used by the US Army and the White House, we were told. But it's actually a Scandinavian design. Scandinavia started manufacturing these batteries. You can see that the dashboard of the vehicle was also built by us. It's totally different. You just push a button, go forward, push another button, go backward. And push one button and you're in neutral. And you can see this was something, first time that Eskom worked together with a vehicle manufacturer to build something. And here is a bunch of people from all over the world. I was also part of the executive committee of the world on electric vehicle programs and technologies, where we discussed the technologies in the various areas of the world. And I invited them to South Africa for 2 workshops. And one of these workshops, I took them to the Kruger National Park because our car was there. And I drove them around. They were quite amazed that we had these things in South Africa. But we operated on lead-acid batteries, and after 4 years, this vehicle batteries was also finished. And they said, you know, what I did is I took this vehicle to the Kruger National Park. I gave them a driver that was there training the people to drive this car for about a year. And then I gave it to them and said, okay, now you've got to do it yourself, drive the vehicle. But they had students. Nothing wrong with students, eh? But they forgot to charge the car. So when they come back from an evening drive, they took the car out at night to drive. And when they come back, they forget to plug it in. They go to sleep. Next evening, they want to drive people. The battery is not full. So out there, in the wild, in the bush, they run out of power. Now, Kruger Park is far from Pretoria and Joburg. So I get a phone call at night. Hey, Carl, the truck is standing. I said, have you plugged it in? No, we never plugged it in during the day. We forgot to plug it in. I said, that's not my problem. So they had to tow the vehicle in. But anyway, after 4 years in the Kruger National Park, the batteries were finished. And they said, you need to buy us new batteries. I said, no, guys, look, I gave the vehicle to you for free. And you can buy the batteries, because every night there's 20 people on that vehicle. And each of the 20 people pay 200 Rand for one ride. And you've done this for 2 years. Do the calculations. You've got enough money to buy the batteries. So that project was very exciting and only lasted a while. Then they, because of the Kruger National Park, Londolozi heard about this, but they don't use these big game viewers. And they asked, can we help them with a Land Rover conversion? So first we took a Land Rover, just an easy one to find, and we converted that to electric. And then they painted it nicely and used that in Londolozi. So Land Rover England heard about this. And after a couple of months, they came and they took that Land Rover to England. And we never saw it again. Funny how things happen. We also converted some of these combi microbuses that we had in Eskom to transport people, to work and back. And we converted these to electric. Now, one I put on the ship and I took to Robben Island, because we demonstrated these things all over the place, and we hope that people will notice that this one is electric, because when you get into an electric vehicle, like you spoke about the bus earlier, it's quiet. You know it's electric. So there you can see Robben Island in front of the ship. I tell you, it's quite an operation to put a vehicle on a ship. But Eskom is not a small company in South Africa. Eskom, at that time, had a very powerful brand name. So if I go to the people on the docks and I say, look, I want to put a ship on the vehicle, I want to take it to Robben Island, these guys are helpful. They don't have all kinds of nonsense. You first have to fill out a tender form and that. I never did that. I had people that wanted to work together and make things happen. And here is a picture of us in a mine in Secunda, one of Sasol's mines, about 2 kilometers underground. Because these vehicles also don't create any emissions that would harm people. The only thing that they were worried about is the sparks of the motor, because sometimes there can be methane underground. And when there's a spark, of course, you can create a fire and explosion underground. And then we did a Jeep Wrangler conversion, and this time, instead of lead-acid batteries, we were using nickel-cadmium batteries. And then we did something that we thought was a good idea. Together with Nissan Sani, the people that worked with Nissan but did their special vehicles, we built a small electric utility vehicle. Now it started off with this idea of this little thing at the right here. I don't know if you can see that. We were looking at niche market spaces for electric vehicles because the battery does not provide you a range to do normal traveling, normal car traveling every day. So we thought while the batteries are still evolving to get better, like the stage where they are today, we thought that we had to look at niche markets. And one of these things that we identified was sites where electric vehicles could operate, where it is very expensive to operate internal combustion engine vehicles, and the electric vehicle can fulfill the specific needs of that area. And we were thinking about vehicles that operate in vineyards and orchards and in packing houses. And we thought that this little small tractor here could do the trick. So it was just going to be a tractor that will pull wagons of fruit in the orchard or in the packing house, or even pull on the apron of the airport, pull the luggage wagon and these type of things. We spoke to them as well. And I just wanted to build that. But then the guys at Nissan Sani, they were then called Composite Fibers, said, no, we got to make it look sexy. So they decided to dress it up nicely, but it's the same thing. And I still believe today that we should build this because it is something that can fulfill a great purpose, especially in Africa. If you make this a vehicle that can travel all terrains, and if you think about many people in Africa carrying their goods to market, this can be something that will help them in a big way. Especially if we build it ourselves, right? If we don't have to import this from China or somewhere. Well, we can even get the Chinese to do it for us. But what do you prefer? Do you prefer to do it yourself? Ourselves. I'm happy to hear that. In the end, I will try and challenge you to do that. Okay, so this vehicle got great attention and people liked it. So the Department of Science and Technology said they are having a stand in Paris. And we were the corner stand in South Africa, on the South Africa stand. That had other people as well, but we were the best site. As you entered the door, there you saw our little vehicle, and we exhibited that in France. Now in Europe, the streets in Italy and those sort of old towns are very narrow, about this width of this table here. And it's difficult for big cars to pass each other there. So we had lots of interest. And so the people said we should make this a delivery vehicle for Europe. So we're still thinking about that, but it's been many years now. So I'm looking at younger guys like yourselves to take this idea from me and make it happen. Currently, I'm an advisor in energy on electric vehicles, so I can advise you. I will help you. I'll give you even more ideas. At the same time, and maybe it was, and I like to think that we got them to think about it, Denel built this hybrid tank in South Africa. We have never seen this in the world. I think this was a world first. And it was a real life vehicle. I had the opportunity to drive it as well and to be inside it. It can do magnificent things. And that also, I think, the Eskom program started the Joule project. You know about the Joule? South Africa's electric car that was built before 2010. But government funding, as they were sort of maybe 25% of the way to make this commercial, dried up. And this is a story of South Africa. It seems like we just can't finish. We also had this small pebble bed project that didn't go. So there's a number of things. Before we get to the final hurdle, we kind of drop the ball. But this one is successful today. The Mellow vans also started in those times to manufacture this delivery vehicle. They thought of a taxi type of vehicle first, but then I think because of homologation reasons, they had to go for the mellow van, and they are now delivering things. This business is actually expanding into Europe now. So they are very successful, doing very well. Started in Stellenbosch. They have incubators at Stellenbosch. I don't know if you have it here, where they have students that are entrepreneurial and want to develop things. There's a space in Stellenbosch University that they call the incubator space. And they have a small office there and a small workshop. And they can build things before it even gets into the market. The university supports them to do that and get even money from outside to get these projects into reality. And then, while I was still working with, consulting to Saneri, I was approached by Winston from Grid Cars. Have you guys noticed the charging stations in South Africa for electric vehicles? Do you know about that? That's the company that's now rolling out charging stations in South Africa. There's more than 400 already. So I was part of that starting that company up in South Africa. And then later left them to join Saneri. But this is one of the early ideas that we had to produce this small commuter vehicle. If you look at cities, problem cities, and that's a topic for another discussion. We can talk about that in another presentation if you want. The problem in the city is really the car. And you find that there's only one person in the car most of the time. So we were thinking that you can make that car smaller and lighter. It'll use less energy, take up less space. And this is the car that we thought could do that job. Because you can park 4 of them in one parking bay, and you drive 2 of them next to each other in one lane. So you can quadruple the number of vehicles, the number of people that move on the road in a city, instead of having traffic jams. You can also, because who wants to own this thing? It's too small, man. My ego is much bigger than this. So what you do is you make this car an autonomous car. So it reads your diary, your Google diary, and it says, no, you're going to be at this meeting at 10 o'clock. So it rocks up at your home or where you are. It finds you because your phone tells the car where you are. It can pick you up, takes you there, drops you off. It has been established that about between 10 to 20 people can share one of these cars. Imagine if your cost of transportation, cost of mobility drops by 20 times, making it cheaper, and it's just you in the car. Drops you off, picks you up. What a wonderful service. Mobility as a service, but that's a discussion for another day. So that's the bottom of the car that we built, and this is me test driving the car. And then we converted a Nissan NP200. This was quite a while after the 1900s when I spoke to Nissan the first time, did the game viewing vehicle. I'm doing electric vehicle program with Saneri. And I need another car to convert. And they gave me the NP200. They said, you can have this car, you can play around, but we don't want to read about this car in the press. So we did, and this is the first car that we fitted with lithium batteries. We had a 70 kilowatt motor in front, and it drove wonderfully. I used it then as my commuter vehicle after the Corsa Bakkie kind of died, because the Corsa Bakkie at this time was about 25 years old. But at Grid Cars, we also thought about building things, starting things from the ground up. So here is the start of a 3-wheeler workhorse. I don't know our indigenous language. A black guy. And he said we should call that. And he said it's a workhorse. That's the name for a workhorse. But anyway, so you can see there we make the drawings on a piece of wood, and then we start building it, putting it together, and this is the first ride. And this can carry 2 drums of compost, water, or waste. And you don't need a bakkie with a crane like they used before. You can just roll up the drum, and when you tilt it forward, it lifts up at the back, and you can drive away with it. And this is a lady that had a project of garbage removal, and we developed something in the back for it to use for the rubbish, to carry the rubbish. So these vehicles can be used in a township. One guy actually came with an interesting idea to me. He said in the townships, people don't always have washing machines. So why don't you put a washing machine in the back and you drive to a tap and you wash the washing for people? Because this vehicle has got a battery inside. The battery can power the washing machine. All you need is water. Okay, here's some more examples of that one. You can carry people, like a feeding service for the taxis. No, there's narrow roads in the townships. Sometimes people have to walk kilometers with the checkers. And you can put groceries in the back. And this is a Chinese import that had an internal combustion engine and that we converted to electric using the motor there. And this one didn't have to have a long range, so we used the lead acid batteries. Yes, question?
So how much would one of those vehicles in the previous slide cost?
Well, that's a prototype. So when we built the prototype, it cost about 50,000 Rand. But that's prototype. Now, if you want to scale up and you want to reduce the cost, that's what you do. You scale up, you make many more of them, and you get a whole range of people together to build a production line. Then you can reduce the cost of the vehicle quite significantly. Like now, Tesla is building a two-seater vehicle that will be a robo-taxi. Like I explained to you earlier with the vehicle that I showed you. And they produce 1 in 11 seconds. And that ensures that the price of this vehicle will be very low. But we'll get to that. So we were also the first people in South Africa that produced a solar charging station. This was at the CSR. We had building number 24. That was our office. And we also had our station outside to charge the batteries for our electric vehicles. So if you charge your electric vehicle from solar, you don't have to pay anything for the electricity. You've paid already for that once off, and you don't pay again. That's also a topic for another discussion, because I drive on solar, and I can tell you, if you're interested, how much money you save on electricity for the home, electricity for the car. It's typically 50% of your expenses. Anybody earning money, doing work, it'll be 50% of your expenses, your home energy and your car energy. Then Sanedi said I must come work for them. So I've got some Sanedi pictures as well. We had a conference at the venue that you can't see, but BMW was very kind to me. They said, why don't you use the Mini? We are doing experiments in the world. They had 900 of these Minis throughout the world. We had 2 in South Africa. They gave me one for a couple of months to drive. Fantastic little car. Now they manufacture electric Minis. One of the cheapest electric vehicles in South Africa. Also, while at Sanedi, we designed this BRT bus. How many of you guys use the BRT bus? Nobody. You've seen the buses there in front here. They were in my way driving here. They are taking up the road, wasting the space. Esh! I need an extra lane to drive in. Now there's a bus lane. And when you look at these buses traveling, there's one, then you wait a long time. The road is empty, nobody's using the road, then there comes another one. And you're not using it. Why are you not using the bus? Don't worry, I don't like the bus either. You're not going to tell me. I think it's wasting space. If you left this space to the taxis, they would utilize that space much better. Much better. They move many more people as well. You will see it's full of taxis all the time. But no, taxis are not allowed to drive there. Don't worry, I'm controversial. I've been called many things many times. Anyway, also there was a Corsa conversion at the University of Stellenbosch. We started working together with them. You can see now the lithium batteries are entering the market. We're starting to use them, starting to learn about them. And we even put up a solar charging station at the IDC. Why the IDC? The IDC is the Industrial Development Corporation of South Africa. They should be funding industrial development. And that's what they do. But our project, I think, was a little bit too small for them. But you can see, yeah, the unveiling, the building of the charging station, lots of people came to take a look at it. It's still working today. I can travel to the IDC, with my electric car, and I can plug in there and charge from solar. If you drive electric and you right-size your car, if you don't have a big car, you have a small car, your commute of 80 kilometers a day will only require about 4 kilowatt hours a day. But your solar installation should be a little bit bigger than that, 5 kilowatt hours, and it'll take about 10 square meters. In South Africa, we have lots of sunshine. So that'll cost you about 30,000 Rand, once off, and that'll last you about 25 years. So the cost of using that energy to drive electric will be about 6 cents per kilometer. 6 cents per kilometer. Guys, you can do this at home. Okay, now if you look at smart cities ideas, I also said I will just touch on the future to give you some ideas of where you guys can do some things. A nice side hustle. Okay, we have to optimize the way we commute. If you look at this commuting, we start at home, you've got to go to a destination. Some people walk, some people cycle, some people get into a taxi, some people drive their own car, and then you get to your destination. We have BRT, we have Gautrain. I've also developed a model that optimizes this situation for electric, petrol, gas, whatever you may think about to power your ride. But that's a conversation for another day. These things exist, we can do it. We've also looked at these sort of pods in the air. We live in 3 dimensions, but we drive only in 1 dimension. So we need to create another dimension if we want to keep up with the population growth in the 3-dimensional areas. All right, so we need to think about putting transport up in the air where they don't have to wait for traffic lights, where there's no congestion. Cape Town now, I mean, I presented to them about 20 years ago. Now they're talking about a SkyTrain. Let's see how that unfolds. So, why electricity? It's about energy. All right, the energy that you choose to power your ride, to power your vehicle. Many years back there was electric vehicles, but the batteries were not great enough, they were heavy. And then the petrol engine took over because of the electric starter. Because previously they had to crank these things. But when the starter came on, that's easier. And then petrol vehicles become much more popular. But energy leads to efficiency. Electric vehicles are much more efficient than petrol vehicles. And I'll show you that soon. And efficiency leads to cost savings and also pollution reduction. Now, if I say pollution reduction, I'm talking about poisoning the air in the city that you live in. If you look from outside, I came from Midrand this morning, and I looked at Joburg, and I saw this brown air that I'm driving into. And I thought, am I going to go in there? Do I go breathe this poison now? I actually didn't want to come here. There's too much poison here. Huh? You kill people. You know how many people we kill every year? 7 million people every year die because of particulate matter that enters the bodies. That's more than COVID. We made a noise about COVID. But who's making this noise about polluting air that's killing people? But the world is full of people. We don't need all of them, huh? No, you cannot say that. Also, the pollution creates global warming, climate change, and all these sort of things, and the world is very much against that. So if you look at the South African energy balance, sorry, cameraman, I'm moving this way again now. And this is a simplified version of that. You can see on the left hand here is our primary energy sources, mainly coal and some crude oil. This was done some years back, and it's not valid for today. We have much more solar and other things coming in. Well, not much, maybe 5%, but it's growing. And this is where this primary energy gets converted into energy carriers. Energy carriers is the form of the energy that we can use to do the work that the energy needs to do. The tool that I'm interested in is your car. And the work that it does is creating kilometers for you. That's mobility, you move. So if you look at the conversion here, it's not very efficient. We have about 50% or even up to 60% of the energy that we buy, we waste in the production, the conversion processes. Eskom is only 34% efficient in coal stations. So 60 plus 66% of the energy is thrown away. And with oil, same thing happens. And then you look at the consumption losses. That's the energy that gets lost in the economic sectors where we use the energy. You can see transport is very inefficient. Only a small amount of energy is used for useful energy, and a bigger amount of this energy is lost in the process of burning the fuel inside your engine. Because 60% of the energy of the tank creates the heat in your engine. So if you think about that in terms of mobility, you can only use about a fifth of the energy that's in your tank, but you pay for the whole tank. It's like eating a hamburger. You want one hamburger, but you've got to buy 5. Guys, does it make sense? But everybody's doing it. You're not thinking. All right, just a good example of that. You remember the lights we had, the ones that became so hot? Now, take a look at this. See, we start with 100 units of energy. We burn the energy in the coal power station. All right, then we produce the electricity. When we transport it, we lose 2 units. In the factory, we used 62 in the power station. We lost 62 units of the energy. And then when we burn the light, we switch the light on, we lose another, well, to power it, it's 36 units, but we lose another 34 units. So only about 2 units of energy of the 100 is used to produce light for us. That's why we don't use those lights anymore. We use LEDs nowadays. We've learned our lesson. We've understood that we're losing all the energy. It's crazy. You shouldn't do this. Unless you have lots of money, you want to waste it. You put fire to your money. Now, in South Africa, we have this situation. We don't have oil wells, but we take the oil out of the ground, we refine it, we distribute it, we burn it in a petrol car. Total process efficiency is about 15%. That's why I said you lose at least a fifth of the energy, 20%. Because nowadays, cars are a little bit more efficient than in those days. In a coal mine, we have a synthetic fuel, that's Sasol, and we burn it, so it's only 7% efficient. So the 93% of the energy that is in the coal is wasted in this process with Sasol. That's why Sasol is the biggest polluter in the world, single point polluter, and creating of these emissions that we don't want. But if we take this energy from the coal mine, we put it in an electric car, then it's already 24% efficient. But we waste the energy at the power station. Then the car efficiency has gone up to about 85% nowadays. But if you use the sun, of course, you can be much better off. So that's why I use the sun to charge the batteries of my electric car. And here's just another example of explaining the efficiency of the internal combustion engine car against the electric vehicle. And you can see we save a lot of money as well. Just to rub it in, make sure that you understand it. They say repetition is good. So at the fuel price of 25 rands per litre, you use about 8 litres in the city commuting. That is about 272 megajoules of energy. That'll cost you about 200 rand. Now you go electric, same car, you use 15 kilowatt hours of electricity. I use slightly less than that. And it'll cost you about 3 rand 50. That is about... Pardon? You're arguing me with about electric price. What you use? What do you pay for electricity? I don't know because I don't pay. I've got solar, so please tell me, what do you pay? Do you know? You don't know? It's too cheap, huh? What are you asking? All the charging stations?
In South Africa, all the charging stations.
No, they're not all solar. But there's a company now, Zero Charge, that is putting in just solar chargers. But in time, they will be more and more solar. But currently they're not. At homes, when like myself, I have a solar on the roof. And because you design for bad days, I have surplus energy. And I use the surplus energy to charge the battery for my car. I don't have to charge every day. So you can see it's about a quarter of the cost in this case. But if you right size your car, you use a small car, you use less electricity, and if you use off-peak tariffs from Eskom, you can reduce the price to about 1 rand. And then your ride will cost you about 5 rand for 100 kilometers. How's that? Now everybody wants electric car. Am I right? Yeah. So just a quick look at the emissions. You can see the electric car does not pollute at point of use, but the petrol car does. And where the energy comes from, this is the power station. That is the normal oil refineries, and that is Sasol. Okay? So in South Africa, even though you use coal-fired power stations, your car is cleaner than a petrol car. That is only where there is Sasol available. That is in Gauteng. If you go to Cape Town, you don't have Sasol, you have nuclear energy. So it becomes much more even then. This is the Eskom situation. You can see the peak. This is a weekday. And you can see the peaks, the morning peaks and the evening peak. That's the morning peak, that's midday, that's the evening peak. And between these two peaks, nobody buys electricity. And we had, not anymore, we had capacity problem. That's why we had load shedding. Eskom could not reach the peaks. And maybe this winter we might experience some of that again, but it's much better now. And if you look at that valley between the evening and the morning peak, we have 38 gigawatt hours of electricity. Now that is enough energy for 6 million electric vehicles to travel 50 kilometers each the next day. Eskom cannot switch off the power stations. They have to idle. So they have to produce electricity throughout the night. It's like an open tap, the water is falling out on the ground. Nobody's using it, nobody's buying it. But if we charge our electric vehicles overnight, we can charge 6 million of them, each traveling 50 kilometers the next day. You can do it for free. Or Eskom will charge you, but at a lower cost, because they want you to charge there and not at peak times. If you do that and you level the demand curve for Eskom, Eskom becomes more efficient. That means Eskom can reduce the price of electricity. This is a quick example. Sorry, I still have 10 minutes. I'll try and finish quickly. This is a quick calculation, just to show you how much money we can save. So this on the left is petajoules. That's the energy in the petrol that we import into the country a year. That is the energy that we'll use if it's electric. Much less energy, at least a quarter of the energy. That is the foreign exchange leaving the country to buy the petrol. Now that is a billion rand. Okay? So we will not have to pay this anymore. But we will still pay this. Well, that's the cost that you pay. That's what the user pay for this import. Okay? 200 billion. It costs the people that import the oil 109 billion, but you guys pay 200 billion because it's made up of the balanced fuel price, margins and cost, and the levies. Now if we change to electric, we can reduce this to 42 billion rand instead of 82. We won't touch the levies and we won't touch the margins and costs. But if you go to solar as a country, we can further reduce it by 50%. And we will only pay, the people will then pay 20 billion rand instead of 200 billion rand. 10 times less. How's that? Of course, people are going to cry about the tariffs and the taxes on the fuel because that's income to government. But government does not have to pay the foreign exchange leaving the country. We are creating jobs inside the country and rather pay our own people for the electricity we can produce locally instead of paying guys outside our country, the guys that produce the petrol and the diesel and the stuff that pollutes our air and makes me not want to come to Joburg in the morning because I see this dark cloud hanging over the city. You can do this at home. This is a diagram. I'm just showing you how you can get energy to feed your home, charge your car. Your car can go back and feed your home again, or your car can feed into Eskom. Now, if Eskom creates tariffs during the day, feed-in tariffs that pays you for energy that you give back to Eskom, say for instance at night, at peak times, They pay you 4 rands for a kilowatt hour, and they charge the users 8 rands. And there's time overnight where you can buy electricity for 1 rand. So you can charge your batteries using 1 rand per kilowatt hour, and you can sell those kilowatt hours at 4 rand. That makes sense, huh? Any one of you who wants to start that business in the township, let's talk. I can help you. So what is happening? In the world now, because the world is now moving to electric vehicles, we need to create the ecosystem for electric vehicles. That is a system of industries that sits around the vehicle, because the vehicle alone cannot operate very well. I know that because in the 90s I drove electric and I was the only one. There were no charging stations. It gets lonely. But every plug in the wall was a charging point for me. But you have to spend some time there. So if I now visited you with my old car, the first thing when I got out of the car, I said, "Where's a plug?" And you will ask me, "Do you have an extension?" I said, "Of course. I can plug in anywhere. I've got a 30-meter cable." And I did that. Every time I visited people, did a presentation, did a meeting, I charged my car. But it's also a nice talking point. When you go to the gym, when you go play action cricket at the gym, I get out, I say, "Where's a plug?" And then they show me, and then you find there's lots of people standing around you asking, "What are you doing with this plug in the car?" and all these sort of things. You've got a nice story to tell. So we're creating this whole ecosystem. Now, first of all, we need to think about where's the energy going to come from. All right? So you've got to think about the power sources. And then you need to think about a smart grid. And I'm talking about a grid that has got variable tariffs that will encourage people to take energy away and sell energy back to Eskom at certain times, working together with Eskom, working together with consumers. They are called prosumers. You produce and you consume. So it's a partnership. And then we also have to think about smart cities, home charging stations, because most of the charging in the world happens at home. 80%. 20% people use fast chargers. And then you need to think about what happens to the batteries after they're used. Now, in the beginning, we thought a lot about that, and we thought there'll be lots of batteries. But now the batteries are lasting so long, we're not too much worried about that now, because the batteries will last 10 years in these cars. And then they have only lost about 80% capacity. But people are starting to feel nervous about the range, so they take the battery out. Now these batteries still got energy, and they use them to power buildings, homes, stand up for backup battery systems. And then we need to think about production of these vehicles. I mean, the first vehicles that came out are vehicles that need to attract attention, to create a market, to make people want them. So they build these very expensive cars with high performance and long ranges and all that. But you don't always need that. You just need mobility on the farm or in the city or whatever the case may be. How far do you travel every day? 20 kilometers? 40, 50? I mean, it's easy to find a battery that'll give you that distance. No problem. So we can make cars simpler, build things for our own use, for our own requirements. And you know, the prices have been falling. The price of solar cells have fell about 95% in the past decades. Batteries, the last 1.5 decades, fell by 90%. The price of batteries. Hey, since I'll come to get you now. And then, of course, the price of energy generation also fell. While you guys look at the graphs, I'm going to answer this question.
Have you ever implemented a management system for the vehicles?
Just talk in the mic, I cannot hear very well.
Or have you
I'm
managed
old,
a battery management system for
Oh.
monitoring the health
You
and
wanna-
state of charge of the batteries?
Yeah,
in
you
the
want to build
vehicle?
a battery management system?
Yes.
That's a good idea. No, all the battery packs do have battery management systems.
Oh.
Now, currently, I'm struggling at home with my own battery management system. I'm a first uptaker. Maybe you guessed that already. I start very early with new things and new technologies, especially when I have an interest in that. So I'm one of the first guys that drive electric. So solar installations, I'm one of the first guys that does solar installations. And I do it myself because I want to learn from this. So my batteries are old batteries. And the battery management system in that is old. So now I'm thinking I need to rebuild the battery pack, but I need a new battery management system for it.
So are you using active balancing or passive balancing?
Passive,
Passive.
yeah. And it happens in a very small voltage range. And that's why I'm struggling with my batteries now. So I want to create it with an active balancing. I need a battery management that can do active balancing. But we shouldn't just have, we should have discussion off this presentation.
Yes.
Anyway, but it's real. There's need for that. So if you look at graphs that manage change. Good morning, you look lost. You're feeling welcome. You're very late. But it's okay. Okay, so this is the scenarios that we are facing today. It's happening. That is the reduction of petrol and diesel cars. It'll follow the S-curve. You've all heard about the S-curve, haven't you? It's the natural phenomenon. Many products follow this. And if you are early adopters, you make your changes early. And if you look at this, the gradient of this graph, it's not very steep. It's always a mountain to climb. Change is not easy because you need to adapt. But the earlier you start with a change, if you identify the change to be real, the better for you. If you wait a long time, and that's what's happening in our country, we are waiting a long time. We are far behind the rest of the world in terms of adopting electric vehicles. We will have a steep curve to climb. So there's pain coming. I mean, in this time, there's no more no more petrol and diesel cars. You will not be able to sell your car that you drive today. You will not be able to get fuel for it. Maybe where we are sitting in Africa, it's going to take a little bit longer before we feel the pain. But if we don't change, we'll feel the pain. So I want you to think about that. I said the battery prices are falling, the battery technology is improving. When I started driving electric, I could only cover 60 kilometers, and I had to recharge. Batteries are finished, 80 kilometers. When I bought my first electric car, I could do 120 kilometers. That was the Nissan Leaf, 120 kilometers. That was the maximum range. The one I'm driving now, I can do 440 kilometers. The next version of the one I'm driving now can do 900 kilometers. It's coming out the end of this year, beginning next year. 900. Geely already said they have a car that can go 1,500 kilometers. So the batteries are becoming better, they're becoming lighter, and they're becoming safer. Everything that you want. Technology is moving. Also, because of the battery prices falling, the electric vehicle prices are falling as well. And scale is going up, so as the numbers going up, prices are coming down. So, and also, the time for the rich, expensive cars are over. The ones that are much more affordable is coming now. The Geely E2 is a very good buy now and will last another 10, 20 years. These are numbers for batteries. I think I spoke about it. I don't have to go into the details. My time is finished. I don't know if I have extra reserve time. 2 minutes. As I just said, this car is a very good buy today. And this is the Neue Klasse that has got the 900 kilometer range. Hey, very nice car. Eh? I wish I can buy it. I'm too poor. And now this is where I come to give you guys the challenge. If we look at this picture here, you can see there's a motor in front of this frame. And there are batteries here. And the BMS is under the seat. It doesn't just control the battery. It looks at the motor acceleration as well, the flow of energy inside the vehicle. We call it the controller unit, much more than a BMS. You might even have a BMS on every battery module and then a central controller. But this is how simple an electric vehicle is. When we started converting vehicles, we didn't know anything about this stuff. I had 4 people, technical people that were just technicians. They were not highly skilled engineers that converted all those vehicles I showed you in front. And I used the first one for 8 years as I trusted the technology and the workers so much that I used the vehicle as my primary form of transport. I drove from Pretoria to Rocheville every day with that car for 8.5 years. I had two times when I had to stop next to the road. But it wasn't a big problem. So that's the battery sitting outside the car, and I mean, the first one, I had an inverter and I had 10 solar panels. And I started. And I didn't pay electricity again. And then I bought some more batteries. And I didn't use electricity at night as well. Didn't have to pay at night. And then Eskom, fortunately, I was busy doing the electric cars, so I found out I can plug in my car and charge my car as well. So I bought more solar panels. Now I was charging my car and I was powering my home. But there's a better plan that you can make. In townships, they are looking for energy, and some people only have a battery that they use. So you create an energy hub in the township, and you charge batteries for people. They pay you. So first you provide energy as a service. You charge batteries off a solar installation there where you live. You stay there. You look after your solar panels. And all the time during the day you charge batteries for all people around. You can use the same battery pack that they use in motorcycles, the swappable pack. It contains about 2.5 kilowatt hours. That's all you need to power a low-cost home overnight. My own home takes only about 5 kilowatt hours through the night. That's the energy I need through the night. I've calculated. When I worked at Seneri, I was driving a Nissan Leaf. I can drive in the morning to work, use about 5 kilowatt hours. I charge at work. I negotiated with the landlord. I say I want to put in a charging station for my electric car. It'll draw 6 kilowatts. He said, how much will you use in a month? I told him. He said, that is so small, I'm not going to even charge you anything because I will not even see your spike on my map. So he allowed me to put the charger in for free. So I can charge it at work. Then I drive home, and I calculated that I can plug my home into my car overnight. And if you add all these costs, you start saving money. If you're patient, you will save enough money to create something new. It takes time. But if you now want to do it in bigger scale, you charge batteries for many people. You can start with a few batteries. And they will tell more people, and they will come. And they will even bring their own batteries to you. They will pay the batteries. And you just charge them. You charge them for the electricity that you produce off solar. It's going to cost you money once. And you'll operate this thing for 25 years. No problem. You got to start small. But you've got to start. If you don't start, you will never get there. It's like running a race. It's not easy. Even running a race, you need to exercise. You need to work hard so that you can run the race. I'm 72 years old. I still run a race. I'm talking about a real race. I take part in the biathlon. I qualified for Northern Gauteng. I take part in essays. This age. Man, you guys have got your whole life ahead of you. Nobody told me these things when I was your age. I had to find it out myself. It's not easy. You've got to start. Don't wait. Start something. Think of something. If I can't motivate you now, I'll never be able to motivate you.
Thank you very much. Do we still have any questions? All right. Before we dismiss. Okay.
No, thank you so much for the presentation. My question is, where do you think as a nation and perhaps as a continent, where did we drop the ball? Because based on what you're saying, we were at the forefront, we were competitive, right? If you said all of this in the early 90s, in the EV race, right? So and of course South Africa is the pioneer in Africa. So why haven't we been able to translate it into much more wider acceptance, even in the continent, and then export it like perhaps the Chinese are doing? That's the first question. Then the second question is, you did mention, and that was a very important presentation, or slide rather, about the EV ecosystem. So there are several aspects, smart infrastructure, smart grid. Where do you think is the quick wins? Right, I know you've mentioned in the townships, right, having charging stations, but where from complex systems theory, there's something we can do that we can get a tipping point and can accelerate the wider adoption of the technology in the ecosystem. Where do you think that is? Thank you.
Good questions. Second one is so difficult, so I'll start with the first one. And that is a difficult one to answer, and I don't want to directly criticize government because I'm not there anymore, so I don't know what is happening inside government. But it might also be that we are just not correctly positioned. And I think it's because we have the perception that we cannot do great things in Africa. You know, if you think you can do something great and you have confidence, then you prepare for that appropriately. But if you don't have confidence, then you give up and you half-heartedly do something and it doesn't get anywhere. I think it's maybe a bit of that. Because if you look at the Jewel project, they had funding in the beginning, but then when they wanted to scale, there was doubt if they will even succeed. The rules were difficult for them. They had to produce 50,000 vehicles in the European market. Now, I ask you, what is that European market going to do with the South African market? And why should we aim for that market? Because we are in Africa. Especially in the beginning, you shouldn't start there. You should first service your own market. So I also believe that they should not have tried to produce a car to start off with. If you try to compete, in the olden days we would have said with Volkswagen, Toyota, BMW, you don't know how the troubles you face. Elon Musk said it, it's like hell trying to build a car, and he's very successful. He's building most of the cars in the world now almost. BYD's got their own problems now, so he's giving them competition. They overtook him last year, but now they're sliding back again. Geely is now going to take the Chinese market. But yeah, anyway, so I think it's a bit of a confidence thing that we don't think that we are that great. We can't do these things. We don't prepare for that. Therefore, the departments that should produce the funding are not really there. They're not. They cannot give the support that they should be giving. And then it's also maybe approaching the market in the wrong way, looking at the European market. If you see a Jewel next to a Volkswagen, next to a BMW, next to a BYD, what are you going to buy if you're a European guy in Europe? You will not buy South African, no. But if you started in South Africa, like we want to build this local little vehicle for the African market to use in niche market spaces where we see it can already perform well and compete well. There's nothing that's going to compete with it now. So it's easier there. The market barriers to entry is much lower. So that is my sort of confused answer to your first question, but I hope it helps. The second one is, remind me.
Where's the easiest entry point?
Oh, the easiest entry points. Yeah, that slide that I showed you was I'm also working with the Western Cape government, and it's for their government fleet that we are looking to create that ecosystem in the Cape. There's also unique problems. It should have been created already, but I'm in a hurry. Some people are not in a hurry. Entry points would be touching, and it will be very much similar to what I said. I think we should look at the easy things first, the simple things. We wanted to build that three-wheeler so that anybody that wants to build this can do it with a screwdriver and a spanner. And we wanted to set up this energy hubs in the townships. We wanted to build the components and put it in a box, and then take the box to the energy shop in the township. And then the energy shop could employ people to fit these parts together to manufacture this three-wheeler. And then this three-wheeler would take children to school, take people to the taxi ranks, do all kinds of jobs inside the township. And the reason why it's that shape and size is because it's difficult to move in the townships. I mean, you all have been in townships. I have not been to so many townships, but when I walked in there, I saw there's not a lot of space, especially in the informal ones. So we wanted to create some work for the guys there and then put up the solar panels so that they can start this charging station, charge batteries for people. But I need somebody that is much more involved in townships than myself, because we need to understand the business very well. I think that is a very nice, easy, simple entry point. Nothing glamorous, but work is not glamorous. When you work, it's a grind. I mean, who wants to work the whole day? You want to work the whole day? Nah. Unless you're passionate about it. So the thing I'm trying to tell you is find your passion. Man, you shouldn't be doing things you don't want to do. Find your passion, like the BMS, and make the best BMS that you can make. There will be a market for that. Provide the best services to people that you can. Find out what people need. So in my looking at these things, I identified those needs, because if there's no need out there, nobody's going to part with money to pay you for anything that you give them. There's a question this side.
Do we still have any question? Okay.
Hi. Stand up. Hi. So I wanted to ask, in terms of the township projects and charging batteries for people, right? So where I come from, I don't know anyone who even has a battery. So how accessible are these batteries? Because when you want to start the venture of charging these batteries for people, you're going to have to supply them with the batteries, you know. And I've never even seen them at any shop.
So there's no competition?
Yeah, there isn't.
But do you think people can use batteries?
Yeah. I really
What are they
believe in
using
the
now?
idea. Right now they're using Eskom's electricity, and they are really complaining about the prices and all that. So I think there's a really huge opportunity.
You see, the interesting thing here is you have a customer that is complaining about the supply of the service. They are saying the prices are too high and it's difficult to steal because Eskom can take a look and they see you've taken it. I've just heard about the theft. Eskom does not like this customer. If you were Eskom, would you want these lots of customers and some of them steal your electricity and it's difficult billing them and all these things? So you need to go into, first of all, negotiations with Eskom. Now you tell Eskom, I'm going to make it easy for you. I'm going to take your customers. I'm not going to steal them. I'm going to take them off your hands because you don't want them. And you must help me to do this business. I'm sure Eskom will help you.
Okay.
Because they're a big utility. They want to have 1 or 2 or 3 customers, not thousands. The municipality wants thousands of customers. Or maybe not. But some customers they like, some they don't. They like paying customers. Townships are not really good paying customers. That's why some areas Eskom or the municipality has got massive debt, because these guys are not paying for the electricity. So we need to find a solution that addresses the problem. But also, when you find that solution to address the problem, you need to find the business so that you can make money in that solution, providing the solution.
Okay, thank you.
I once wanted to take cooperation off the grid, and I had to negotiate with various people to enable the project. I negotiated with Eskom because it was their client. There was a township nearby as well, so the township was also Eskom's client. So I had to speak to the municipality and said, the corporation that uses most of the electricity, they're going to become my customer if I make them run on solar. I said, it's okay, but what are you going to do for us? I said, well, I'm going to help your township as well. They say, how are you going to help the township? I say, I'm going to design the system in such a way that the co-op will always have electricity. So there's going to be an over-design. I'm going to design for surplus. So when I have surplus, during those times of the day, I'm going to give it to the township. I will tell the township so that they know, so that they can use the electricity for free. I will not charge them for electricity because the corporation would pay for the whole installation, everything. And then I negotiated with Eskom. They said, it's fine, you can take the customer. Eskom actually said they would fund the battery that I would install there because they needed some information on how it's going to work. It was still early days. And I negotiated with the municipality. They said, it's fine if you take our debt of R1 million. I said, it's okay. I will negotiate with Eskom. I'll pay off your debt. Because there was enough money that was going to be generated in the project. And then I also had to negotiate with NERSA. I tell you, it's not easy to talk to all these three guys. The times that you have to wait, but it's worthwhile doing that because there's goodwill there. People see a solution and they want to make it happen if you explain it properly. We have to take the time to do these things. Not always easy, but it's possible.
All right, we'll take one last question. For everyone who still has a question, please send your question to blockchain@uj.ac.za. But I'll take one last question.
Greetings, sir. I have one question. So is there a way to contact you, maybe like if you have increase in stuff, like if you have many questions, you are as you presented, I'm inspired by what you have presented, and I would love to maybe take a certain path in that direction. Is there a way, direct contacts we can?
I have provided my contact details on the first and the last slide. So I've also given you a copy of that, so it is available.
Okay, thank you, sir.
And guys, I don't have IP on these ideas. I don't want ideas to sleep. I want ideas to run. But I can't run so fast anymore. So I need somebody that can run fast. Not to make a business for me, but to make it for yourself. That's why I like to do these presentations to young people. You are the future. I want you to create a good future. I still want to live in that future. I don't want to see us fail. Thank you. Thank you for listening to me.
Thank you very much, Mr. Sia. I'd like to invite Professor Johnny Dladla to present our gift to our guest speaker for today.
Good morning, everyone. You know, we all came in ties and suits, and I had to be orange so that the security guards could open for me. What a pleasure to be in the company of the young, bright future minds. I learned as much as you did this morning. I'm not sure if they did make you aware that after this there's an exam paper. So it was a surprise. I'll be marking the exams. So for those students that have asked questions, those will be the questions that will be in the exam paper. So I hope you understood the answers. Firstly, let me thank Mr. Snyman. Mr. Snyman and myself come from Eskom. We were at Eskom in 1992. I think most of you were not born yet. And here we are. He told you that he's 72, which I still don't believe him, because he looked younger even then. He's even looking more younger than myself. So I won't tell you how old I am. If he's 72, you can tell I'm around 80s. Carol, thank you so much for a very enlightening presentation. This is the future. When he started the electric vehicle at Eskom, nobody understood it. And when we came to Eskom, we were brought in to create some excitement at Eskom. I think your parents, I would take that chance, they would know that Eskom started having brands, Electrowise, Agri-Leg, Industrial-Leg, Commercial-Leg, because we're trying to make sure that people understood who's attending to their needs in the market. Because Eskom is to everyone, is to business, is to people at home, is to people in the commercial space, and he was bringing electric vehicles just to make sure that everybody understands and appreciates the use of electricity. Now, we are in a department that is very exciting at UJ. I think it's the most, he spoke about the car had to look sexy. I think the department you are with in engineering here, it's sexier than the engineering that some of us have seen and know. Am I correct? Yeah, and we have to make engineering sexy because they tend to see it to be very too serious, very focused. Just make it exciting, and that's when you'll enjoy engineering. I'm part of this faculty. I was appointed as a professor of practice, and it surprised me actually, what am I going to discuss? Because engineering people are just too serious. And I must say the 2 years I've spent here working with Professor Nandi and his team, it has really made me feel at home. So engineering is no longer boring for me. I just want to touch on the SDGs that are on this. And I was saying to Professor Namdi, we actually practically delivered on these SDGs. If you look at starting with SDG on the affordable and clean energy, EVs talks to clean energy. If you look at the industry, the infrastructure, it talks to that infrastructure. But I just look at all these SDGs and I found that if we start looking at the price of electricity compared to fuel prices, that start talking to addressing the zero hunger, because then you can afford to have extra money to be able to feed yourself. So it talks to that SDG as well. If you look at the clean water and sanitation, if you start having clean energy, we are able to also start looking at how do we contribute in improving the environment. Because if you improve the environment, that then talks to, you can be looking at the clean water because of the water not being polluted. Now we talk about partnerships. The questions that were asked here about how do I charge if I don't have to drive 100 kilometers in the rural area, that's where you partner. That's where the businesses come in. And that's what Mr. Snyman was talking about. I just thought I'll just make it more practical. I'm the professor of practice, and I only look at practical stuff. Now, when you look at those 5, just in case an exam question comes after this meeting as to, please explain how the 5 SDGs, these are the Sustainable Developmental Goals that the UN has put in place. That's how it looks like when it happens practically. And I hope I've managed to just sum it up for you as to how all of this is applied after theory. I just thought I'll wrap up with those remarks. But Carol, thank you very much. And he acts very fast. I met him on Monday. We're just reconnecting after 40 years. And today is Friday. He's here. He has spoken to you. So that's an action man. So when he speaks about participating and being healthy and staying young, this is young. This is what young looks like. And I think you can identify with the young people today. Thank you so much, sir. I know you are retired and you don't work for Eskom, so you don't need to declare this. This comes from, and we are not corrupted here, so we're not looking for any favors, but just to say thank you very much.
Thank you. Thank you for giving me this opportunity, Johnny, and thank you guys for allowing me here today. It was really great talking to you all. I hope I see you some of you in future. Thank you.
Thank you once again, everyone. And with that, we have come to the end of today's seminar. I hope we learned a few things. If there's one thing I want us to go home with, it's EV is a balance between cost, efficiency, and better economy. So I hope we would do well to take this point home. Thank you, everyone. I'll see you again in the next seminar. Bye, everyone. Unfortunately, today, we didn't make provision for refreshment. But I can guarantee you that you would have that next time you come.
the contact thing.
Right?
Yes.
Yes, I would share that with you.